This is video on friction. This is the third video in the series. We are looking at problems, and this is the second video on the problems. First problem. It says block A of weight 300 newtons rest on block B of weight 400 newtons. Block A is restrained from moving by a horizontal string tied at point C. This is point C. What force P applied parallel to the plane inclined at 30 degrees. See, this P is parallel to this plane. This plane is inclined at 30 degrees horizontal. Is necessary to start block B down the plane. Start block B down the plane. And what they have given us is mu is equal to 0.35 for all surfaces. In these like problems, the first step is draw free bodies of all the bodies, that is A and B. So here for B, we are trying to draw all the forces. See the weight, the normal reaction from this A, and the two frictional forces. Now you have to note that reaction will always be perpendicular to the surface which it is touching. So this is perpendicular to surface of A, this is perpendicular to surface of the plane. Weight is always downwards, and friction will be at the surface, and it will oppose the tendency of motion which is downwards in direction of B. So both surfaces there is opposition, and frictional force is mu r. So that's why this mu is written here 0.35 and corresponding r's. So this completes free body B. Similarly, we are going to draw free body of A. The tension R2. R2 is coming out from this surface, okay, which is surface of B. Then in addition to this, there is friction, which is opposite to this friction. The reason is when you put A on B, you should, all forces should at the surface should cancel out, and you should see clean figure like this. That's why, because 0.35 R2 is this way here, it will be opposite here, and R2 down here, R2 up here. Now that we have drawn all the forces, all we have to do is write sigma fx0, sigma fy0 for each of these bodies. Now, when bodies are on incline and their surfaces are parallel to incline, it is convenient to take x-axis along the plane and y-axis perpendicular to the plane. So when we do that, for the first body, sigma fx, that is all forces in x direction, come to t cos 30, because see this angle t makes with this incline is 30, minus 0.35 R2 and minus 300's component in plane direction, that is x direction, that is 300 sin 30. Similarly, in y direction, it will be R2 minus 300 cos 30 minus component of this t sin 30. Third equation will be for sigma fx for this body B. So it will be P minus these two frictional forces, 0.3 R51, 0.3 R52, plus component of 400 in the plane direction. So 400 sin 30 is equal to 0. And finally, sigma fy f for B is R1 minus R2 minus 400's component perpendicular to the plane, that is 400 cos 30. Now we need to solve all this. So solving 1 and 2, which is very easy, we'll get R2 and T, and then using this value of R2 in 3 and 4, we can easily get value of R1 and P mainly, which is of interest. Answer is 226 newtons. Okay. Let's look at second problem. It says determine the necessary force P acting parallel to the plane, this force, to cause motion to impede. Assume coefficient of friction as 0.25 and the pulley to be smooth, and of course string to be inextensible. So what you do in this case also do same thing. Draw all the forces on each body. That is, draw free body of each body. See, the rule is same. A reaction comes out from the surface perpendicularly, tension away from the body, reactions on the body, and friction opposes the possible motion. Now see, only way this system can move is this body will go down, so this body will move towards left. So friction here is towards your right, and friction here is up because body wants to move down. Now the masses are given here, and we have taken G as 10. We have taken G as 10. All right. Then in this case, if you write now all you have to do is write sigma fx, sigma fy for each of them. So I write for this T minus 0.25 R1 is 0 and R1 minus 1350 is 0, telling me, the values of R1 and T. But before that, let's write this equation. Now here, because it is on incline and body's sides also parallel to incline, what we can write is see T minus this one now, P minus T minus 0.25 R2 plus 450 sine 45 is 0. That is all forces along the plane and all forces perpendicular to the plane. R2 minus 450 cos 45 is 0. So I have these four equations. So 1 and 2. See, 2 gives straight away R1 and putting that 1 gives straight away T. And using this T and R2 in 3 and 4, we will get P as 98.85, which was what was required for us to find. So this is how we have tried to do. We have followed the similar steps and done this second problem. Thank you.